Okay, so for the last chapter that we're going to be covering in this class, it is covering trigonometry, specifically with right triangles. You have learned this before in geometry. There's three functions you've learned before: sine, cosine, and tangent. Remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, there's three more trigonometric functions: cosecant, secant, and cotangent. Cosecant is opposite of sine, so it flips the fraction. It's hypotenuse over opposite, or we can write it as 1 over sine. Secant is hypotenuse over adjacent, which is opposite of cosine. And tangent and cotangents are opposite. So the way I remember this is cosecant and secant look the same but spelt backwards. Cotangent and tangent both have t's, and then sine and cosecant are the leftovers. Okay. Also, it's important to remember the Pythagorean theorem is a squared plus b squared equals c squared. C squared is always the hypotenuse. Okay. It wants me to evaluate the 6 trig functions of the angle theta. So right now I know my two side lengths, 5 and 12. It doesn't matter which ones I make a and b. I just need to make them. So I have 5 squared plus 12 squared equals c squared. And I need to solve for c so I know what the value of my hypotenuse is. 5 squared is 25. 12 squared is not 12 squared. It's 144. Equals c squared. Okay, so what we want to do here is I want to add 25 plus 144 is 169. Then I want to go ahead and take my square root of both sides, and I get c equals 13. Okay, now what I'm going to go do is I'm going to go label my triangle according to adjacent, hypotenuse, and opposite. So hypotenuse is always the longest side. Opposite is the one that doesn't touch the angle. So this would be my O, and this would be my adjacent. So then I'm going to go through and fill out my 6 trig functions. So for sine of theta, I have opposite over hypotenuse, which is 12 over 13. For cosine of theta, I have adjacent over hypotenuse, which is 5 over 13. And for tangent of theta, I have opposite over adjacent, which is 12 over 5. And I leave these as fractions, and I just need to simplify them if I have to. Okay, then there's cosecant, which is the opposite of sine, so 13 over 12. Secant, which is the opposite of cosine, which is going to be 13 over 5. Cotangent, which is the opposite of tangent, which is 5 over 12. Okay. On number 2, it wants me to find the 6 trig functions again, but this time I have my hypotenuse given. So what I want to do is, this is going to be my c, a, and b. So I have 5 squared plus b squared equals 7 squared. And then I want to square out my numbers, so I have 25 plus b squared equals 49. If I subtract 25 on both sides, I have b squared equals 24. Now, when I try to take the square root here, it doesn't come out nicely to a nice square root. What I want to do is I want to break down my radical and use the factor tree. So remember, it's even, so I have 2 and 12 as a pair of factors, 2 and 6, 2 and 3. I want to look for pairs. I have a pair of 2's right here. So b is going to be 2, because the pair comes outside, and the leftovers, the ones that don't have pairs, get multiplied and stay on the inside. So I have 2 square root of 6 as my b side length. Then what I want to do is I want to identify my opposite, hypotenuse, and adjacent. So opposite, adjacent, hypotenuse. So I'm going to go plug those in. Sine of theta is opposite over hypotenuse, so 5 over 7. Cosine of theta is adjacent over hypotenuse, so 2 square root of 6 over 7. Tangent of theta is opposite over adjacent, so I have 5 over 2 square root of 6. I do not want to leave the square root of 6 on the bottom, so what I do is I'm going to multiply the top and bottom by the square root of 6 to get rid of it. And I end up with 5 square root of 6 over 12. Because square root of 6 times square root of 6 equals 6. 2 times 6 is 12. Okay. Then I want to find my other 3 trig functions. So I have cosecant, which switches sign. It's going to be 7 over 5. I have secant, which switches cosine. So I have 7 over 2 square root of 6. I want to get rid of that square root of 6 on the bottom. So I multiply by square root of 6 over square root of 6. This gives me 7 square root of 6 on the top, 12 on the bottom. And then I do the same thing for tangent, cotangent. And I'm going to flip the first one I had, because if I flip this one, it's going to give me a square root on the bottom. So then I end up with 2 square root of 6 over 5 for my cotangent. Okay, so what I want you to do right now is pause the video. Take a few minutes to work on the 2 on the back, and then when you're ready, click play, and I will solve through the 2 on the back. Okay, so this one on number 3, I need to figure out my hypotenuse first. So I have A, B, C. I have 7 squared plus 24 squared equals C squared. I know 7 squared is 49. Let me grab my calculator to figure out what 24 squared is. It's 576. Okay. 49 plus 576 is 625. I know this one. It's 25. Okay. So then what I want to do is I want to go find my, I'm going to label this one 25. I'm going to find my opposite, adjacent, and hypotenuse. So hypotenuse is the 25, opposite is the B, adjacent is the 7. Then I'm going to find my 6 trig functions. So I have sine of theta, which is opposite over hypotenuse, so 24 over 25. I have cosine of theta, which is adjacent over hypotenuse, so 7 over 25. And I have tangent of theta equals opposite over adjacent, so 24 over 7. Okay. Then I switch these for my other 3 inverse trig functions. Reciprocal trig functions. I have cosecant, which is going to be 25 over 24. I have secant, which is 25 over 7. And I have cotangent, which is going to be 7 over 4. Okay. Number 4, I need to find the value right here. I'm going to make this A, this is C, and this is B. So I have 8 squared plus 3 squared equals 9 squared. I have 8 squared. 3 squared is 9. 9 squared is 81. I subtract 9 on both sides. I have a squared equals 72. Then I want to take my square root. 72 is not a perfect square, so what I want to do is I want to factor tree this. I have 2 and 36. 36 breaks down to 6 and 6, so that can come outside. I have 6 square root of 2 for my A side length. Okay. Then I'm going to label them. This is my hypotenuse. This is my opposite. This is my adjacent. I'm going to find my 6 trig functions. I have sine of theta equals opposite over hypotenuse, so 3 over 9. I can simplify this one, so it's 1/3. I have cosine of theta, which is adjacent over hypotenuse, so 6 square root of 2 over 9. I can simplify this because the 6 and 9 are both divisible by 3. So I end up with 2 square root of 2 over 3. Then I have tangent theta, which is opposite over adjacent. So I have 3 over 6 square root of 2. So what I'm going to do is before I do any simplifying, I'm going to get that 2 out of the bottom. So I multiply by square root of 2 over square root of 2. This gives me 3 square root of 2 on the top, and then square root of 2 times square root of 2 is 2. 2 times 6 is 12. Then I want to simplify this because 3 and 12 are both divisible by 3. So I have square root of 2 over 4. Okay. Then I have cosecant, which flips the sign. So instead of having 1/3, I have 3 over 1, or just 3. Secant, I flip this, and I have 3, that's not a 3. I get 3 over 2 square root of 2. Remember, I can't have that square root of 2 on the bottom, so I want to multiply by the top and bottom of square root of 2 over square root of 2. I get 3 square root of 2 on the bottom. Square root of 2 times square root of 2 is 2, times 2 is 4. And then I want to have cotangent of theta, and I'm going to flip this one. So I have 6 square root of 2 over 3, and then the 6 and 3 can simplify. I'm left with 2 square root of 2.